Hi again. We are still in chapter 19 of the Black Book, section B. This is example number 2. So I'll talk you through this. This video might be a little bit longer because there's a lot to go over. But just fast forward through what you don't want to listen to. First things first, you should always read the problem, make sure it makes sense. The botanical gardens have been trying a new chemical to control the number of beetles infesting their plants. The result of one of their tests are shown in the table. So they have 5 samples. They listed the amount of the chemical in grams, and then they counted the number of surviving beetles after applying that. So 2 grams, they had 11 surviving beetles. 5 grams of chemical, they had 6 surviving beetles. 6 grams of chemical, they had 4 surviving beetles, etc. So the amount of chemical is our X value, and the number of beetles left depends on that. So we know that that's our Y value. So first thing they say is draw a scatter diagram for the data. So in order to do that, we need to make sure that we understand which variable is which. So we just talked about that. The X value goes on the X axis. So that's our quantity of chemical. Looking at the range, that's 2 to 9. So I basically counted from 0 to 10. For our Y axis, our range is from 3 to 11. So I counted from 0 to 12. And then I just plotted the points. So this first point here, this is 2, 11. Here we have, this happens to be the 3, 6 value. This is the 5, 6 value. And then these are the other 2 values. I labeled my axes, etc. So first of all, does this graph make sense in the context of the story? Yes. As we apply more chemical, we would expect there to be fewer beetles left. Great. Okay, part B, determine the correlation coefficient. So here's where you need to use your calculator to do some stuff. There is one thing that you have to do first before you can use any of this, and you need to make sure that your stat diagnostics are on. So in order to do that, you are going to hit mode, and you are going to arrow down until you hit stat diagnostics. Notice mine were off, so I'm going to turn them on, and then I can second quit out of that window. If you don't turn those on, you won't get an R value when you do these calculations. All right, next thing, I'm going to enter my data in the same way that I've always done. So I hit stat, I choose edit, and then I'm going to type in the data. So I had 2, 5, 6, 3, 9. Those are my X values. And then I'll arrow over and I'll type in my Y values, 11, 6, 4, nope, 4, 6, and 3. Again, your calculator will do what you tell it to do. So if your data is wrong, it will give you an answer, but it won't tell you that it's the wrong answer because your data is wrong. So take a second and double check that your coordinates match up. So I have 2, 11, I have 5, 6, I have 6, 4, 3, 6, and 9, 3. All right, good to go. So the next thing I'm going to do, I'm going to hit stat. I'm going to hit calc. Because we are calculating stats now. And now we have 2 variable stats. So I choose that. My X list is L1. My Y list was L2. I don't have a frequency list, so I'm just going to calculate. And here it is. All of those stats with 2 variables. So that's all the stuff that we knew before, all our other values. Notice R is not there. So what we really want is to calculate our linear regression. So that's number 4. Linreg and we want it in the form of ax plus b. If you keep scrolling down, there's another one. There's a linreg where it's a plus bx. We don't want that. We want ax plus b. Notice there's also a quadratic regression, a cubic regression, a quartic regression. If you keep going, there's a natural log regression, an exponential regression, logistic, a sign regression. So there are tons of different regressions that you can do, and those are all depending on what you think your data looks like. When I look at my data over here, it looks linear, so we're choosing number 4, linreg. I have X in L1, I have Y in L2. It's not frequency. If I wanted to store the equation, I could do some stuff here, but also I can just write it down. So I hit enter. Here we go. This is in the form of y equals ax plus b, which is the same as y equals mx plus b. Our a value, or our slope, is negative 0.9666. Our b value, that's our y-intercept, is 10.8. R squared is 0.738. And r, which is the thing that we are looking for, is negative 0.859 if we round it. That being said, since R value is negative 0.859, we then describe the correlation between the quantity of chemical and the number of surviving beetles. I should use those words in my answer. Use my little table. This is between, this is in the moderate category, and it's negative. So there is a moderate negative correlation between the quantity of chemical applied and the number of surviving beetles. That's it.